Welcome, this is Algebra 2-1, Unit 1-3. You guys are going to love this today. We are going to go out of the box for your thinking, okay? You're going to feel so smart when you leave my class. I'm just super stoked. Okay, so we're going to draw the line, circle the creepy dude, and solve this problem. Going up our PIMDAs. Hopefully you were in my Algebra 1, so you know all this that I'm doing. It's so much fun. So first thing, by this creepy dude, ask me about the creepy dude in class if you want the full story, but this is creepy dude, and we want to get him alone because he's in the park on the teeter-totter. We're trying to keep it all balanced, not have him run, and we say, okay, let's get him all alone. Way to do that is to get rid of everything around him on his side of the teeter-totter. So we go up the PIMDAs to do that. What's being added or subtracted? It's being subtracted, it's a -1. We want to add then, +1. What we do to one side, we do the other, otherwise the teeter-totter would flip and he would run. So, we cross that out. That's the whole point of that. If it didn't cross out, then we did something wrong. X squared equals 1. Now, is there anything being multiplied by the x squared? No. So we don't need to multiply or divide. Now we're at exponent. What's the opposite of x squared? Well, maybe I should say opposite. What's the inverse of x squared? Well, the inverse of x squared would be square root. So the way to get rid of a square is to root it. But what we do to one side, we have to do the other. And we have to bring in the plus or minus. That is because if I simply say square root of 1, I ask myself, what would multiply to equal 1? Well, it could be a +1 times +1, or it could be a -1 times -1. That's why we have to introduce that. So, square root of 1 is 1, so we have plus or minus 1. There's our answer. Kind of cool. Huh, interesting. We have two answers, and our exponent was 2. We're going to watch that in this class. Okay, now watch what happens here. We go up our PIMDAs. We see we're going to subtract. Get your spotlight on the creepy dude. Okay, this wipes out. X squared equals -1. To do the inverse of x squared, it would be square root, plus or minus, and we get x equals plus or minus square root -1. And in Algebra 1, you started going, oh, that can't happen. No real solution. And I hope your teacher emphasized no real solution. Because, ta-da, today in class, you have just been introduced to an imaginary solution. Imaginary. Radical -1 is what we call I. I has a value of radical -1. And so now we're going into imaginary numbers. Don't get freaked out. It is so awesome. You guys like sci-fi. Just put a little bit of music on here like okay, so going back to our first lesson in class, we had our box, remember, like our UPS box, and they shipped us real numbers, and we had all different things in there. Well, real numbers can be written as a plus bi if the b is equal to 0, because 0 times radical -1 would be 0, so you just end up with a real number like what you've known real numbers to be in the past. Nothing new there. Okay? I just want to show you how it could be written as a complex number, because this is our topic, complex numbers. Now, these new imaginary numbers, they show up in this imaginary box. That's why it's kind of faded out. It's like Twilight Zone. Oh man, we could get so into this. My brain is going, you guys. But a plus bi, where b doesn't equal 0, means that you've got an I in there. You could have -4i. 7 plus I, radical 3. 2 minus I. Anyway, I'm getting way too into it. Okay, pure imaginary numbers means, oh, let me back up. Imaginary numbers means that it's a real root plus an imaginary root. Neither one can be 0. That's when we have a mix there of them. Okay, oh, in fact, this one should have been maybe like 3 minus 4i. Okay, now, otherwise it would be a pure imaginary number, and it should be in here. Okay, now, pure imaginary numbers means that the a value is equal to 0. So it's just a 0, and then your b value can't be 0. Okay, so this would be like 2i, I radical 2, I, what I had up there, negative 4i, that would be a pure imaginary. There's no real number to it. Okay, so now let's look at what we can do with them. These are real numbers. If we're saying to add, just take your real numbers and add them. These are the imaginary numbers. Just to add them together. It's just like when you used to have 8 plus x and 7 plus x, and you'd add the real numbers and then you'd add your variables. Well, now you're just going to take your real numbers and then you're going to add your imaginary numbers. It's no different. So, kind of use the commutative property there. Now we're going to use the associative property. 8 plus 7 is 15. Plus 3i plus 5i would be 8i. Don't make these harder than they are. On this one, make sure that you realize you are subtracting each one of these. I usually tell kids, just distribute that negative before you even get going there. And oftentimes up here, I'll write them vertically. Here I definitely like to write them vertically. So as I distribute, I go negative 1 times 7 is negative 7. Negative 1 times 5i is negative 5i. 8 minus 7 is 1. Positive 3i, negative 5i, negative 2i. If you struggle with integers, positives and negatives, please snag me this week in class and tell me you want to work with me with the chips just for a little bit. Man, it can bring clarity in no time. Last kind of problem that we'll do in this lesson is multiplying. Now, hopefully, you've been in class where we've been practicing box or FOIL, but I'm just going to demonstrate it here with imaginary numbers. In class, we've been doing it with just the like 3 plus x and 2x minus 5. You know, we've been doing it with just regular binomials, but these binomials have imaginary. Don't get freaked out. Here's the box method. I notice this is 2-term. I notice this is 2-term. Doesn't matter which one I write on which side. I just write them on each side of the box. And this is just like back in like 4th grade when you learned about the multiplication table, and you would say 8 times 6, and you'd go out here and you'd find the square of the answer, and it was 48. 9 times 5, 45. 8i times 5, that would be 40i. 9 times 3i, 27i. Now, just like in the other binomial multiplying that we've done in class, if you're going to have like terms, they'll be diagonal. Both of those do have an I, they can be combined. 8i times 3i would be 24i squared. Now, a minute ago, I introduced you to I being radical negative 1. Well, what's I squared? If I is radical negative 1, does it make sense I squared would be radical negative 1 times radical negative 1? And have I shared with you guys the story of the prisoners and how we always get prisoners out? And in the radical case, this is equal to radical negative 1 times negative 1. Get him out of prison! He's got his twin there! So we immediately take him out of prison. I squared equals negative 1. Yeah! So every time you get an I squared, you can see that as times negative 1. So 24 times negative 1 would simply become a negative 24. And now these are like terms. So bringing that off the box would go 45 minus 24 plus 27i plus 40i. Now, do the associative property. Combine your like terms, 21 plus 67i. Okay? Make sure as you're writing notes, if you have questions for me to go over tomorrow in class, that you highlight those. Now, doing this the FOIL way, I just wanted to bring a different problem in, show it the FOIL way, because we've been doing that in class too. First would be 8 times 4, that's 32. Outside would be 8 times negative 2i, which is negative 16i. Inside, 12i times 4 is positive 48i. And last, 12i times negative 2i is negative 24i squared. Now remember, an i squared means negative 1. Negative 24 times negative 1 would make that a plus 24. So now rewrite it using the commutative property. Whoa, my pen's dying, sorry. Weep, weep. 32, because it was dying. 32 plus 24 minus 16i plus 48i. Combine your like terms. 32 and 24. 56. 48 minus 16 would be a positive 32. And there's your answer. Okay? I don't care which way you do it, FOIL or box, but be able to work with other people that may do it a different way. Okay, that's the end of this lesson. Thank you.